Today's lesson is on future and present value of annuity due in business maths. My name is Justice Johnson. You are welcome to Maths Solution. Now, if you are new here, I would like to advise you or encourage you to subscribe. And as you subscribe, also click the bell icon so that you will be notified each time we upload a video. And also, I would like to encourage you to watch our previous videos on this series and also every other videos that are in there, because they are designed to help you. And share this video, tell people about it, and I'm sure in so doing you will also grow your skills in maths. And please, if you are just viewing this video and you've been watching all our videos but yet you've not yet subscribed, please, I would like to encourage you to please subscribe, encourage us in this channel so that we can be able to post more videos. So subscribe and you can go on ahead to enjoy these lessons. Now let's get right into our lesson today: future and present value of annuity due in business maths. We are going to start up very quickly with the definition of annuity due. And from what we have here, an annuity due is an annuity in which payments are made at the beginning of each period involved. So unlike what we did in ordinary annuity, here in annuity due, payments are made at the beginning of each period involved. So let's get right into the future and present value formula of annuity due. Let's start up with the future value formula. So for the future value formula of annuity due, we have F equals to M, then we open this bracket, then we have our 1 plus I, then power n plus 1, then minus, we have 1 plus I, we can close this bracket this way and divide everything we have here by I. All right, now please, I just like as I did in the previous lesson, in this particular lesson, I will also want to be using this formula. Instead of writing the I at the denominator, I'm going to write it up and take the inverse of it. So we say I inverse, then we can go on to say 1 plus I power n plus 1, then minus 1 plus I, and then we can close the bracket. So this is what I shall be using in the examples here in this lesson. Now, for the present value also, I'm going to be writing it this way, okay? So for the present value, first of all, we have our m, then into brackets, we have our 1 plus I, then minus 1 plus I power minus n plus 1. We can close the squared bracket and divide by I, which can still be written as mi power minus 1, then into bracket 1 plus I, then minus open bracket 1 plus I power minus 1 plus n. So these two formulas are the formulas we shall be using for the present, for the future and present value of annuity due respectively. So now that you've known the formulas we make use of, let us get right into example. Let's take just one example in this lesson. All right, in the example here, we have find the future and present value of an annuity due on 30,000 naira for 6 years at 5% compounded semi-annually. All right, so let us analyze this question by taking the solution. We are going to take the solution and write out all the parameters in this question out. So yes, it is find the future and present value. So we are solving two questions in one, okay? First, we are going to look for the future value, then the present value of the annuity due. Now, we are told that the money that is, we are going to look for the present and future value of the annuity due is 30,000 naira. That means that the catch will be what? 30,000 naira, okay? And the time is 6 years, so we have T to become 6, and now we have the annual rate for as 5%, so R will become 5%, which is 5 divided by 100, and if we do this division, we are going to have 0.05. We've done this in previous lessons, okay? Okay, now let's move on. Then we also told it's compounded what? Semi-annually. Semi-annually means that the n will become equals to what? To 2. So n will be equals to 2. So having gotten these parameters, we can now proceed to get the value for I, which is the ratio of R towards n. And in this case here, our R based on what we've gotten here is 0.005. Then we're going to divide that by our n, which is 2. And if we divide this value by 2, we are going to have 0.025. This is going to be the value for what? For I. Okay, now for the n is a product of n multiply n and t. So we have our n as 2 and our t as 6 based on what we've gotten here. T equals to 6. If we do that multiplication, we are going to have 12. So the value for n is 12. So now what do we do with these values? The first thing we are going to do is to look for the future value of annuity due. So the formula for the future value of annuity due, I've already told you. We have F equals to what? Ni power minus 1, then open bracket. We are going to have our 1 plus I. We close the bracket, then we have n plus 1 minus, then we have 1 plus I, then we close our squared bracket. This is the formula we are going to be using. So let's go over to this place, put our equality sign. Then our m is 30,000. We'll write it out. 30,000. Now multiply by I. Our I is 0.025. So we have 0.025 power minus 1. Then we take our squared brackets and we write our 1 plus 0.025. Then we have here our n. N is 12. So we say 12 plus 1. Then minus, we open the bracket, 1 plus, what do we have there? 0.025. Then we can close the squared bracket. Sorry for that. Now we can move on ahead to simplify everything in the bracket by adding this to this, and it also reflects here. Then we have 30,000 multiplied by 0.0, then 25 power minus 1. We open the bracket. If we add this to this, we have 1.025. Power what? 12 plus 1 is 13. Power 13. Then minus, of course, you know what this is. If we add 1 to 0.025 to give us 1.025, then we can close the squared bracket. So at this point, we are going to use our calculator to get the answer directly. So here we go. We take our calculator, we turn it on, and then we say 30,000, which is 30,000, all right, multiply by 0.025 power. Here, you press our power minus 1, then you have this, then open bracket, that's the open bracket, then we have 1.025, 1.025 power what? Power 13, so we have 13 there. So power 13, and then minus 1.025, and then we can close the bracket and press our equals to. There you have it. You're going to have 424,213.25 kobo. So we're going to transfer that answer and put it here for the future value as 424. Then we have 213.25. So here is the future value for that part on that particular amount for the annuity due. Okay, so now we've gotten this value. The next thing we're going to do is to get the present value. Okay, for the present value, we are going to use the present value formula. We are going to use the present value formula, which is P equals our N I power minus 1. If you recall, I've already told us I'll be using this. Okay, so then we are going to have, open our bracket here, then we have 1 plus I, close the bracket, then minus, we have 1 plus I power negative N, N plus 1, yep, N plus 1. Okay, so that's what we are going to have. And as you already know, we are going to apply all these values we've gotten here. We are going to plug them into this formula. So our P would become M, based on what we've gotten is 30,000. We'll write out our 30,000. Then times our I, you've seen the value for I as 0.025. We have 0.025. Then power minus 1, that's what we have here. Okay, then we can go on to open the bracket and to say 1 plus 0.025, can close the bracket, then minus 1 plus 0.025, then power what? Minus our N. Our N is 12, so we say minus 12, then plus 1, and we can close the squared bracket. Now let's go on ahead to add up what we have in the brackets there. So our 30,000 will still be multiplying 0.025, then we say power minus 1, then we can add up this 1 plus this will give us 1.025, then minus, do the same thing, 1.025, then power what? Minus 11. Okay, minus 12 plus 1 will give us minus 11, so that's what we have here. So at this point that we've arrived at, we are going to do what? To use our calculator and do the same thing there. Okay, so 30,000, that's it, 30,000, that is 30,000 multiplied by 0.025, then power minus 1, you press that, and then you're going to have this. Then we say open bracket, then we have 1.025, then minus that same value, 1.025, then in this time around we are going to say power what? Minus 11, then we close the bracket. Okay, so that is what we have. We can now press our equals to, and then we are going to have 315,426.26 naira, as you can see there. So therefore our P would become 315, then 426.26. So there you have it. This is going to give us the value for the what? Future value of what? Annuity due. Now we've come to the end of our lesson for today. As you can see the example, we just do just one example. And before we wrap up this lesson, I would like you to try your hands on this particular question. There are 2 assignments here for you to try your hands on. As you can see it being displayed on the screen. And as usual, send the answers to me. Forward it into my email. You will see my email address or addresses in the description link under this particular video. I would like to see you in my next lesson. Until then, remain blessed.